26. For the following piecewise function, determine the answer that best describes it. Okay, it says both continuous and differentiable, neither continuous or differentiable, continuous only, differentiable only, has a cusp point at x equals 0. Okay, so pretty much what we have to do is we have to find out if this function is continuous. So it has two rules. That's what a piecewise function is. It's a combination of rules. So like if you were greater than 0 or equal to 0, you use this rule. If you're less than 0, you use this rule. So you have two different rules here. So if I draw my graph, at 0, we have one rule on the right side. Let's put x minus cosine x. And then we have another rule on the other side, which is x squared minus x minus 1. Now, if we just look at each of those rules one at a time, look at this one. Is that one continuous everywhere? Yeah, it's a quadratic function. You know that. And therefore, you also know that it's differentiable everywhere. Okay, it's nothing special. That rule is a well-known rule. This rule right here is a little weird. It has x, which is continuous everywhere. That's just a line. And you're subtracting this cosine x rule. And you know, so x looks like this. It's just this line right here. That's how you get all the values for it, all the y values. Then you have cosine, which, and it says negative cosine, so it's flipped, so it goes like this. Now, both cosine x and x are continuous everywhere, and they're differentiable everywhere. There's no sharp points or turns or anything like that. So this rule is going to be differentiable everywhere and continuous everywhere also. So what really matters is what's happening at 0. If you were to plug 0 into this guy, like if I want to find the limit, so you find the limit as x approaches 0 from the left of x squared minus x minus 1, what would it be? Now, you guys know limits, right? All you got to do is first try to directly substitute. And if I directly substitute 0 into this, it's going to be 0 squared minus 0 minus 1, which equals negative 1. So this rule over here is going to be approaching negative 1. So it's going to be approaching, like this is negative 1 right here. Whatever the line looks like on the left side, it's going to end right here at negative 1. And then, and we're not actually allowed to plug in 0 to that, so we're going to leave an open dot on there. Now I'm curious, what happens at 0 for the other rule? So I'll take the limit as x approaches 0 from the right side of x minus cosine x, and you kind of do the same thing. All you got to do is plug in 0. We don't have to get fancy with the limit and stuff. So I plug in 0, I get 0 minus cosine of 0. I know that cosine of 0 is 1, so we have 0 minus 1, which equals negative 1. Hey, check that out. So whatever this function looks like on this side, it's going to equal 1. And so now I know that we're continuous. If we go from this rule on this side to this rule on this side, it's going to be continuous. The question is, though, are we going to be differentiable right here? So we definitely know we're continuous. So it's not going to be differentiable only. It's not going to be not continuous, okay? We just don't know if we're continuous only or if we're both continuous and differentiable. The cusp point, I don't know yet. I mean, that's kind of a weird one because if we're continuous only, then it might also have a cusp at that point. So really, if this answer is right, then this answer might also be right. So if I were to guess, I would go, okay, A is the answer. But we don't have to guess. We can actually find out if we're differentiable. So what you do to find out if you're differentiable is you find the derivative of the left side. What is the derivative of the left side equal right here? And what is the derivative of the right side equal right here? So I'm going to take this, find the derivative, 2x minus 1. And then I'm going to, so I'll call this f prime. It's f prime. We'll say left side right above it to kind of label it. F prime at 0. That would equal 2 times 0 minus 1. So it looks like the slope on the left side is negative 1. Hey, it's the same as the y value. That's kind of fun. Not really. That's confusing. Yeah, I agree. And then the right side, let's find the f prime of the right side and plug in 0 as well. Okay, so this is right side. We would get 1 minus, plus sine x, and we're plugging in 0. So we would get 1 plus, what's sign of 0? That would be 0. So we get 1. Well, that's kind of crazy. What? So look, the slopes do not equal. One is -1, one is 1. That means the connection right here is not going to be smooth. It's going to be a sharp point. Okay? So,
Mr. Patey,
yeah,
for the left side equation, isn't it supposed to be 2x plus 1 instead of minus 1?
it totally is. You're right. Good call. It looks like I accidentally wrote a negative right here, but it's a plus right here. So, booyah. That's a plus, which means this is a plus, which means this is a plus, which means that's a positive. Okay, so now they equal each other. This is going to be our answer. Wow. Now, I hope that your question is, right now you're thinking, well, what if they didn't equal? Huh? Huh? Well, it wouldn't be a cusp. It would be a sharp point. A cusp goes like this. Okay, it kind of looks like that. That's what a cusp would be. A sharp point goes like this. Okay, so that's not a cusp. So it would have been continuous only if this was minus and this was plus. But no, this is our answer. Looks like I messed up on copying the rule. That was kind of dumb. But anyways, oh snap! I wonder if that would change. Oh no, that wouldn't change this answer because even if this was plus, we would still get -1. All right, so the answer is A. It's both continuous and differentiable.